Hi, it's Tong Woo-kyung, and I'm gonna talk about third week review. And before I start, I wanna say that I'm sorry that I'm late. Yeah. And first, I'm gonna introduce the structure of MOSCAP. There is MOSCAP, and top part is made of metal or silicon. Second one is thin, and it's made of oxide. And this one is called body or bulk, and it's made of semiconductor. So there's M for metal, O for oxide, and S for semiconductor. So that we call MOS cap and capacitor for cap. So MOS cap. Okay. And I'm gonna talk about the states of MOS caps. And there are actually 4 states, like this. 4 states. This one is called flat band. Yeah, flat band, thermal equilibrium state, and accumulation, depletion, and strong inversion. Before we start to draw, there are 2 things we must consider. First one, Fermi level has to be always constant. And second one, the conduction band between oxide and gate and oxide to body are the material properties, so it has to be fixed, right? So let's see first our equilibrium part. This material is, this offset is material property, and this one is also same. So let's see accumulation first. When there's minus for bias for gate and plus bias for body, then we call it accumulation. Why? Because when we offset material, so when we go like this, we can see Fermi level is this, and more closer to conduction band. So we can see that there are many charges accumulated here. I'm sorry, but I said wrong. If we can see the Fermi level close to valence band, so we can see there's accumulated. Compared to there is like more farther than this one, right? But here it's closer, so we can see there's a lot of holes. That's why we say accumulation. And depletion, when there's plus bias for gate and minus bias for body, we call depletion, because the Fermi level and valence band goes farther, and because they're depletion. Why? Because there are less mobile carriers and only fixed charges appear, so we can see there's our depletion. So that's why we call it depletion. And last, strong inversion. When there's much more depletion, much more plus bias and much more minus bias for body, and you can see more like this flexible, and the most important part is, let's see, Fermi level and conduction band, really close, even closer than valence band. That means it can also seem like n-type. N-type, it can also its function is also like n-type semiconductor. Yeah, n-type semiconductor. It is the point of this strong inversion. I think these are the most important for this class. Thank you.